In Antwerp, Belgium, a satellite the size of a washing machine is being built. This mini-satellite, Proba 2, is due for launch in 2009 as a secondary satellite in the SMOS Earth observation mission. It'll weigh between 120 and 150 kilos, and being small has particular advantages. We can cut costs, and at the same time, we want the satellites to be really advanced and autonomous. Moreover, Proba stands for prototype for onboard autonomy. By cutting costs, we also open the way for a certain number of industrial partners, small and medium-sized companies who want to control a project from start to finish. This is the Deze satellite tracking station in the Belgian Ardennes. It's the control centre of the mission Proba 1. This first Proba satellite weighed just 95 kilos at launch and is the older brother of the small satellite being built back in Antwerp. The European Space Agency conceived the Proba missions as a way of testing technology that allows satellites to be more autonomous with the minimum of intervention from the ground. On a polar orbit 700 kilometers above the Earth, Proba 1 was predicted to last 2 years, but has now been working for 7. Its main mission is Earth observation using its hyperspectral spectrometer that offers several images in different frequency bands that go from the visible to the near-infrared. Proba 1 can take a photograph of a given point on Earth every 6 days. This allows around 200 scientific groups involved with the mission to have very regular updates on their given subject. Scientists' requests for observation can be met very quickly, within 48 hours maximum, much faster than the period of days or weeks needed for larger satellites. Unlike most satellites whose instruments move to point themselves at the object they're observing, the Proba satellites simply move their whole body in the right direction. They do this through a system of motorized wheels which rotate them around their own axis. Small, low-cost satellites like Proba also provide the benefit of giving smaller countries and companies access to space.
Building such a satellite is a big endeavor because it's a very complex instrument, but for the size of our company, it's very feasible to do so.
They may be small, but the Proba satellites are highly sophisticated devices that are effectively made to measure. Proba 1 is a demonstration of satellite autonomy technology with an Earth observation instrument on board. Proba 2 is all about miniaturization to go further with this idea of autonomy, and this time there are instruments for observing the Sun, so it's a combination of the two. Proba 3 is a real technological showcase to demonstrate formation flying. That's to say, creating large orbiting structures, not by building one large satellite, but by using several satellites that work together. These tests in formation flying will open the way for future ESA missions like Darwin, which will involve several spacecraft to detect Earth-like planets. So what started as a low-cost way of testing new equipment in space has now evolved into missions with very specific goals and with a much longer life expectancy. The incremental development of these technologies is leading to a whole new capability in space exploration.